Cool. Well, thanks for coming tonight. I'm going to talk to you about building next generation web apps with Blazor. This is a very code heavy talk. Okay, I'm going to do a few intro slides to sort of introduce you to Blazor in case you don't know anything about it at all. And then I'm going to go over into Visual Studio. I'm going to spend probably around 45 to 50 minutes actually writing code rather than sort of looking at slide decks. So hopefully it'll be an interesting talk for you. I'm just going to introduce myself. My name is Chris. I'm a principal software engineer at Deployed. We're a startup in London. We're using Blazor ourselves to build our front-end applications. I'm a Microsoft MVP, have been for a few years now. I used to do a lot of blogging. I say used to. I haven't had much of a chance over the last year because I've been writing a book for Manning called Blazor in Action. So for anybody who just won their Manning ebook, I'm not saying that there's one you have to buy, but you should definitely consider this one called Blazor in Action, I feel. Outside of doing that, I also do a load of open source work as well. So I maintain a bunch of libraries that are under an organization called Blazor, which is going pretty well. I think we went past about 1 million downloads about a month ago, which is good. And it's kind of nice for me to see as well for the Blazor community side of it, that Blazor's sort of getting that much interest. So I think that's a good gauge for what's going on, which is all healthy. Anyway, enough about me. Let's talk about what we're going to go through tonight. So as I said, I'm going to do a quick intro to Blazor, and then we're going to go off into Visual Studio. I'm going to kind of cover 4 main topics. So I'm going to give a brief overview of the app we're going to work with, and I'm going to talk a little bit about how I like to structure applications, and especially Blazor applications. One of the things I find with people who are new to Blazor is that Blazor is a very unopinionated framework. Microsoft are sort of working very hard to not tell you how to write apps. The problem is with that, everybody wants to know how they should write an app and how they should structure it. So I'll give you a bit of an opinion on how I do it and what's worked well for me and the teams I work with. Then we'll dive off into forms and validation, and we'll understand how that works in Blazor and how extensible that bit is, which is quite cool. We'll talk about JavaScript Interop as well, because I know lots of people like to tout Blazor as the JavaScript killer, but I see it more as a sort of another option rather than killing one off. And I think there's a lot of advantages to be had by taking the best of both worlds and putting them together. And JavaScript Interop is really nice in Blazor. The APIs are well designed, as hopefully I will show you. And then finally, we'll talk a bit about authentication and authorization, and that gets a bit technical, but it is going to kind of show you a bit of the inner workings and what goes on behind the scenes. Cool. So let's get going with what is Blazor. Well, Blazor is a component-based framework for building interactive UIs. This definition has actually changed a little bit. It actually started off as Blazor is basically a SPA framework. Well, it's grown beyond that already. In the 3 years that it's been around, Microsoft has taken it from being sort of used as a rival to frameworks like Angular and Vue.js and React. And it's now looking at it much, much more widely. So they're looking at it for building things like desktop applications and mobile applications. So it's got a very interesting future. So how can it be this flexible? Well, it's mainly down to the way it's been built. Blazor's got this really nice architecture where you've kind of got a nice separation of concerns. You have its app and component model, which is basically how you write applications. And this is the syntax we use as developers. This is the APIs we use, things like this. But this has been separated from where the application can actually run. And these are called hosting models. Now, in the code base, they're actually called renderers. And essentially, what they allow you to do is render that component model wherever you can programmatically do it. So, for example, in the box, Blazor ships with a web renderer, which, as you can probably guess, knows how to render out web pages and HTML, and it understands how to work with a browser. But you can easily swap that for a renderer, for example, that knows how to work with native mobile UI or desktop UIs and things like this. So it's a very interesting architecture, which creates a lot of possibilities, which is, I think, what we're starting to see at the moment. So as I mentioned, web is kind of the key one at the moment. It's the production supported model for Blazor. It's been around for a while now. It's getting more and more popular. More and more people are starting to take notice of it. In terms of Blazor server, which is one of the web-based hosting models. That's been around for getting on for 2 years. And WebAssembly has been around for a year now, so over a year actually. So things are sort of maturing nicely. But as I said, there's also a desktop model. Now, this is currently something that's in preview with .NET 6. And this is going to longer term fit into the evolution of Xamarin Forms into what's known as MAUI and .NET MAUI. So at the moment, this is taking a web-based approach, so very similar to like Electron, where you have essentially a web view that you can put into a desktop application, and it's got a mini web server in there, and it can render out your HTML components. So you still author the components in the same way between the web hosting models and the desktop hosting models, except when you are running in the desktop, you can get access to a lot more stuff like, you know, the user's file system and, I don't know, network access and all this kind of stuff. And there is another experimental one that's been sort of boiling around or bubbling around for a while now, which is a mobile implementation. Now, this one's different to the others. This one is called Mobile Blazor Bindings, and it's headed up by a guy called Elon Lipton at Microsoft. And what this is using Blazor's programming model on top of the same infrastructure as Xamarin Forms. So what this means is you can use the same programming model as you would do with web-based Blazor or desktop-based Blazor, except this time around, it actually renders native mobile UI. So that could be a native Android app, that could be a native iOS app. This isn't, at the moment, as I said, desktop is in preview with .NET 6, but mobile is experimental, okay? Microsoft are using this as kind of a feel out for whether developers will like it, and getting sort of feedback about how it would work and things like that. But they haven't committed to it yet. This isn't something they said they're going to ship, whereas the desktop one, that will be in .NET 6 come November. So as I alluded to a minute ago, there's two web-based hosting models, and you've probably heard of these if you've heard anything about Blazor at all. So the first one is Blazor Server, and the other one is Blazor WebAssembly. Now, Blazor Server is actually the oldest of the two. It's been around longer. And this model is quite interesting. As you recall at the start, I said there's this separation between the app model and hosting models. One of the great things that allows with Blazor is for things to run in different places. So with Blazor Server, what happens is the actual Blazor framework and your application code is still running on a server. It runs on top of the full .NET runtime. And what happens is the small JavaScript runtime is downloaded to the browser, which sets up a SignalR connection. And over that SignalR connection, all of the events, all of the interactions the user has with the application are sent back to the server. The server processes them, calculates new UI updates, and then sends those updates back over the wire, over SignalR. And then this small renderer in JavaScript updates the physical page. So this is a very interesting hosting model. A lot of people look at this and usually they sort of balk at it and go, well, there's no way that can be performant if I've got all of that chit chat going on. But it's actually an interestingly very performant. The team have done some experiments where relatively sort of low powered sort of S1 level sort of instances of app service in Azure could support 5,000 concurrent active users. So it's you know, it's a pretty decent hosting model. I personally feel, for me, this one sits though squarely in the realm of sort of intranet applications. I think internal corporate applications is great use for this, and that's because the one kind of the kind of big Achilles heel of this is it does need a stable internet connection. If you lose any connection to the server for any number of seconds, you kind of get this translucent overlay on the UI. You can't interact with the app. It's not a great experience. So for me, that's kind of where I think it suits best. But there are public Blazor server apps out there. And then we've got Blazor WebAssembly. So this is the one that usually gets people the most excited. And this one is exciting for one special reason, and that is because we're running .NET code in the browser. Now, this usually draws a comparison to Silverlight. I can understand why there's a comparison to Silverlight here, but this is truly a totally different beast. Silverlight needed a proprietary plugin. It wasn't based on web standards. it didn't work on mobile devices because plugins didn't work on mobile devices. Blazor WebAssembly is totally different. It is built on web standards. Okay, WebAssembly is a web standard. It's officially the 4th language of the web now. It sits alongside HTML, CSS, and JavaScript. It was officially ratified last year. So it's not going anywhere. What's really interesting about WebAssembly is it does open the web up. It allows us to compile different high-level languages down to this common assembly language or assembly-like language and run it in the browser with near native speeds, okay? Which is a really interesting thing, I think, as a web developer going forward, because choice in the web is not something we've had. It's always been HTML, CSS, and JavaScript. Blazor is it's probably fair to say Blazor is the most advanced WebAssembly framework out there. There are other languages who are compiling to WebAssembly. Rust and Go are 2 of the main ones. But I think it's probably fair to say in terms of feature sets and maturity, Blazor is the most advanced so far. Now, in this model currently, what happens is we actually download regular .NET DLLs into the browser, and we also download a .NET runtime. Now, the .NET runtime is based on Mono. Even in .NET 5, it's still based on Mono. But it is a bit of a special runtime. It's been pre-compiled to WebAssembly, and that's where the WebAssembly name comes from. One, again, common misconception to people new to Blazor is that your app gets compiled to WebAssembly, and it does not, currently speaking. In .NET 5, your application is compiled regular DLLs, and they are shipped, and they're actually executed on this WebAssembly runtime using an IL interpreter. So what this means is it's not amazingly performant. If you're doing CPU heavy tasks, it's not going to do particularly well because of that interpreter. What's coming in .NET 6 is something called AOT. Now, this is where we do compile our apps to WebAssembly, hence the name AOT, ahead of time. So we're going to ahead of time compile our application down to WebAssembly. And at that point, you're looking at about a 5 times performance increase. It's a huge increase. So that's a very interesting one. Of course, nothing in this world comes for free, and there's a trade-off there. By going to AOT, we get much better performance. We get sort of rivaling JavaScript and better than JavaScript performance in some instances. However, we're paying about a 2 times increase on app size, okay? So there is a trade-off there. A lot of people, again, also think that AOT will make the app smaller. It doesn't. It makes them bigger. Cool. So I've gone through sort of the highlights there. Some of the sort of main benefits of using Blazor Server are small payload, fast startup time. Blazor Server apps will start up almost instantaneously because there's next to nothing to download. They're pre-rendered by default, which again helps with that feeling of starting up quickly. You have access to the full .NET runtime because you are running on the server. So that's quite cool. And also you have code security, which is something that .NET developers new to Blazor often don't think about. If you've done any JavaScript work, it probably seems obvious, but Blazor WebAssembly does download your code to the browser. So if you have intellectual property there, you probably don't want to be using Blazor WebAssembly. The trade-offs, of course, for Blazor Server are we now have a much heavier load on the server. The server has to maintain the state of all of these connected clients because it's basically like a thin terminal style approach. So you have to have more CPU cycles going on Azure, more credits you're spending. You do need a constant internet connection. You can't have any offline capabilities here. And latency really does matter. Around 200 milliseconds is your limit. Once you start to go above 200 milliseconds, there will be some lag in the UI, and that can cause a not great experience for your users. What this kind of means is really you want a server and clients on the same continent largely. Obviously, in a big continent, you want a few servers spread around. So for Blazor WebAssembly, the pros here is that it runs entirely client side. So you can offload a lot of the grunt work to all these clients, and you can save some CPU cycles on the server. It's really easy to make Blazor WebAssembly into a offline capable app, or as a PWA as they're known. In fact, if you're creating a new app, there's actually just a checkbox you can tick at the point of creation, and that will just add in the service worker and the manifest JSON files for you, and it's automatically a PWA. Interestingly as well, Blazor WebAssembly apps are compiled down to static files. So what this means is if you're building a standalone Blazor WebAssembly application, so for your API is hosted somewhere else, or you're not sort of looking after the API, you can deploy one of these apps to free hosting services like GitHub Pages, Netlify, I don't know, Azure Blob Storage and Azure Static Websites and S3 buckets and all this kind of stuff, which is a new thing to us in the .NET world. We've never been able to use these free providers before because we've always needed a runtime on the server. Well, that's not the case with Blazor WebAssembly. And one of the big things, and I think this is a huge one if you're a .NET shop, is code sharing. Okay, I've built apps for a long time using Angular as a front end and .NET as a back end. And it's happened more times than I'd like to admit that we've had TypeScript models get out of sync with API models and weird errors happen, and tracking those down can not always be the most obvious thing to do. They don't always take a huge amount of time, but they do take time, and that adds up. With Blazor WebAssembly, we can create shared models. We can put them in a .NET class library, and we can just reference that library from our WebAssembly project and our API project, and we can just use exactly the same files, which means if there's any updates, we just do them in one place and they're automatically in both of our apps. So that is a huge benefit between the two. In terms of the negatives here, as I mentioned earlier, it's slower for CPU intensive tasks because it is running on that IL interpreter. However, like I said, that is going to be mitigated in .NET 6 when we'll have the opportunity to do AOT. And compared to some JavaScript, it can seem like a large download. The kind of file new Blazor project in Visual Studio will kind of come in at around the 2 meg mark once all of the IL linking that it does on a publish is complete. IL linking strips out all of the unused code in the framework and things like that to try and make the app as small as possible, sort of in a similar way to tree shaking does in JavaScript. But it's around 2 meg. Now, I've worked on Angular apps, to be honest, that have been upwards of 20, so I don't see this as a huge deal myself. But if you are critically sensitive to every byte or kilobyte of data that you're shipping to your client, Blazor WebAssembly might not be the right option for you. That is it. That is all my slides. Okay, we're gonna leave PowerPoint alone now, and we're gonna go over to Visual Studio, and we're gonna start working with Blazor and get a feel for what it's like to use. So what I'm going to do is I'll quickly start off by showing you the app that we're going to work on for the rest of the talk. So this is this fictional Blazor repairs company. And what we've got is we've got a few screens here, but there's not a lot going on. This dashboard doesn't have anything. This new repair doesn't have anything. The only thing that actually works at the moment is view repairs page. Okay. And what this is doing is it's talking to an API and it's just loading up some static data that I've stuck in there. Okay. So what we're going to do is we're going to work through and sort of kind of fill out these bits that are sort of needing some attention here. So let's go to Visual Studio. So the first thing I want to point out is I'm using a Blazor WebAssembly app here, and I'm using a specific template. I'm using the Blazor WebAssembly ASP.NET Core hosted template, which is a lovely succinct name. But what this means with this template is that we get not only a client application, which is a Blazor WebAssembly project, we also get a ASP.NET Core Web API project to serve that Blazor app, and we also get a .NET class library to share code between those two. This is a great template for me. I think I really like this one because I think it's a good start for building real world apps. Now, I'm not going to show you around the other bits yet. We'll see them as we go, but we're just going to talk about this client project, which is the WebAssembly one. So by default, as with most Microsoft templates, the default structure is based on type or responsibility. So you end up with a pages folder that has page components in it, or routable components. And you end up with a shared folder which has shared components in it. I'm not a very big fan of this type of structure. I find dividing by type is not a very good way to maintain applications long term. A very long time ago, when I very first got into front end development, feature based folders were sort of coming in, and I've always found them incredibly useful and a very good way to organize applications. So in a feature folder world, what we do is we create a features folder, and inside of that, we create a folder for each feature of our application. Everything belonging to that feature then lives in that folder. This has got a number of benefits. One of them is that if you're someone new to the app, it's easier to discover all the features that the app has. If you're going to work on a feature, it's easy to find the files you want to work with because they're all in one directory, they're all in one place. The discoverability is really easy. And another thing that I really like about this is it fits well with my personal preference on back-end architecture, which is vertical slices. So where I'm currently at Deployed and also at my previous company, we use vertical slice architecture along with feature folders in our Blazor apps, and they kind of match one-to-one. So we had a feature in our front end that mapped to an endpoint on our back end, and that was a complete vertical slice, and a developer could work through the whole stack really easily. That question? No. So that's what I've set up here. Another reason I've done this is to make the point to people that there's no conventions in Blazor. If you're coming from like Razor Pages or MVC, for example, or maybe not Razor Pages, but certainly with MVC, there's a convention around where stuff needs to be. It needs to be in certain folders. And if it's not in certain folders, you have to tell the framework where to find those files. That's not the case with Blazor. Blazor can discover what it needs to discover using reflection. So it doesn't really matter where you put them. Organization is really down to you. So if I just expand a few of these files, you can see most of them have just got single files in. However, like things like the login one here, which we'll touch on later, that's got a SAS file with it. I like to use SAS for my styling. But this is a good example where you can put stuff together, and we'll see this kind of grow as we build out some of these features. So what I'm going to do is we're going to start off with this forms and validation stuff. So if we go back to the app, we've got this new repair page that we need to update and allow us to add a new repair to the system. So we're going to start off with that. And we're going to start off with a sort of a basic HTML form and see what it's going to be like to work with that in Blazor. So this is our new repair page. One of the conventions I like to use as well for page components is to stick page on the end of them. It just makes finding them easier when you've got a feature folder structure because you might end up with a few files. Page components are simply regular components in Blazor that have this page directive at the top. And what this means is Blazor is going to load this page when we go to whatever route we specify. And we do that by setting the route inside of these quotes. So this particular page is going to load up whenever we go to /repairs/new. Cool. So let's get the first bit of code on here, and we'll get going with this. So I've pasted in a chunk of stuff here, but really the only bit I want you to focus on at the moment is this bit in the middle. And this is just a regular HTML form. Okay. So this is using normal HTML paradigms. We've got an action attribute here of where we want to send our form, where we're going to post it, and the method that we're going to do. So I've just plopped that in there for the moment. And we're just going to run the app and see what this looks like. Okay. So we'll let that go through. Cool. So this is what that form looks like. Okay. But right now it's not a lot of use to us. If I hit save, we kind of get a not very useful error message. Well, or an error message, sorry. And basically what it's saying is that we don't have a supported media type. And that's because I'm trying to post an HTML form to an API that's expecting JSON. So that's not going to work. So how can we make this form sort of Blazorified? How can we work with it in Blazor? Well, we're going to go through a few steps. The first thing I'm going to do is I'm going to add this new field into my component. And I'm going to do that inside of the code block. Now, the code block is somewhere we can write C# code. Any C# code is valid here. I can put classes in here. I can put properties in here, methods. It doesn't matter. Any valid C# can go in this chunk here. So I'm just creating this new field called repair model. Now, this repair model sits in my shared project. And what it does, it just represents the data I want to collect in this form. Okay, so that's all I've got here is just a few properties that are going to hold the data from the form. So now I've got that, what I'm going to do is I'm going to update these HTML input controls, and I'm going to bind them to that model. So what I've done here is for each of the individual inputs, I've used Blazor's bind directive, and I've basically said bind the input to a particular property on the model. Okay, and bind is a two-way binding mechanism in Blazor. Okay, so this would work both ways. If I was trying to edit a form, for example, and my model already had values, when I loaded this up, for example here, name would be pre-populated with whatever data was in my model. Okay, so it's a two-way binding mechanism. So I've got that in place. I'm going to jump back down onto my code block now, and I'm going to add in a method. This method is called handle form submit. And as you can probably guess from the name, it's going to handle when we submit the form. And what it's going to do is it's going to take that model and it's going to serialize it, and it's going to post it back to our API in JSON format, okay, which is what our API expects. And I'm using one of the HTTP client JSON helpers to do that. If that goes through successfully, we get a successful response code back, then I'm just going to show a success sort of message at the top by setting this Boolean to true. And then I'm going to new up the repair model, which will effectively blank the form ready for a new entry to be added. The final thing I'm going to do is I'm going to update this opening form tag. And what I'm going to do is I'm going to bind my form handler, my form submit handler, to the on submit event of the form. Now, anything that's Blazor based starts off with one of these @ symbols. Okay, so this is kind of the same name as a JavaScript event, but it's got an @ symbol in front, so it means it's going to be handled by Blazor instead. So what I'm saying here is, instead of doing your default action when I submit this form, I want my handler to deal with it instead. So I'm going to rebuild now, and I'm just going to go back to our form, and we're going to refresh this. So let's see what happens now. Let's try and fill this out. So let's say he's got a broken tap. He's a plumber. And we'll put a contact number in and hit save. So good news. We've got a success message has appeared at the top here. And if I go to my view repairs, you can see that we've got John Smith in the system now. So in a few lines of code, we've been able to take a regular HTML form and we'll be able to deal with it now in Blazor, and we're working with it in our C# language, which is a nice thing. And as you can see, hopefully, it wasn't a huge amount of work for us to get that form working with Blazor. But we do have some problems. If I hit save now, this still says that the repair's gone through successfully. And if I click on my view repairs now, I've got bad data in my system. So that's not a lot of good. We need some way to validate what we're doing. So let's go back and have another look at our repair model. So what I'm going to do is I'm going to take this repair model. I'm just going to update it with this bit of code. And what this has done is it's just added data annotations to this model. Okay, so data annotations being the kind of default validation mechanism in ASP.NET Core. And all I'm saying is my name's required. I've got required in a min length on my issue, and I've got this really easy, succinct regex expression for phone numbers. You all understand what that's doing, so I won't go into detail about that, and we'll move on. So we've got that in place now. Now, the really cool thing now is I'm going to just do a quick rebuild on that now, let that go through. So I've done nothing but add data annotations onto my model. If I go back and I reload my app now, and I come to my new repair page and hit save, I'm clicking away, but nothing's happening. If I go into my browser tools, I'm now getting a 400 coming back. And if we go on the network, you can see that we're now getting validation errors back from our API. So just by adding those in, we've kind of secured our API from bad data, which was sort of relatively painless. So that's good. But we've still got a rubbish experience for the user. We've got no feedback here to tell them that they've not filled out the correct data. So let's fix that. So what we're going to do is we're going to take this form and we're going to replace it. We're going to replace all of it with a component called edit form. Now, this is a component that ships out of the box with Blazor. And as you can see, it's a drop-in replacement for the form element in HTML. Now, this is where the power of components come in. By using the edit form, we get access to a lot more interesting stuff. And one of the key bits is validation. So in order to work with an edit form, we have to provide it with a couple of bits of information. Firstly, we have to tell it the model that we're going to be working with. Okay, so we're just going to pass it that same repairs model that we had before. And we also have to tell it what to do when we submit the form. So it has a slightly different syntax for handling submits. It actually has 3 different submit events. So it has on submit like we had previously on the HTML form. But that's a bit rubbish because that means that we have to still call validate on our model and make sure it's all valid ourselves. I'm too lazy for that. A far nicer way is to use onValid submit. Now, as the name probably alludes to, this method or this event, sorry, will only call your handler if your model has been validated, which means our handler can be nice and clean. It can be sort of happy path only code because the model must be valid in order for that handler to be called. So I really like that. The third one is one called on invalid submit. Now, I've not really found an amazingly great use for that. Knowing that a form was invalid for whatever reason, I haven't found a great use. I haven't really found anyone who has found a great use either. But if you do find one, let me know, and it is there if you want to use it. The other thing that happened when I pasted in this code was I've updated the input elements to be components as well. So Blazor ships with component versions of all of the regular HTML elements. So we've got an input text instead of an input type text. We've got an input text area, an input select. There's also input radio, input checkbox as well. We just don't have a use for them here. In a similar way that we did with the HTML inputs, we bind to them using a two-way binding. The slight difference here is because we're binding to a component, we bind to a property within a component. And I'll show you an example of that a little bit later in the talk. But for now, just know that a component exposes properties, and we're going to bind to one called value. So that's what this slightly different bind syntax is saying. I'm saying bind the name property on my repair model to the value property exposed by my input text component. Okay. So that's all we need to do in terms of the edit form and getting it up and running and configured. The last bit I'm going to do is I'm going to stick in another couple of components here. One is called data annotations validator, and this other one is called validation summary. Now, data annotations validator tells the edit form what validation mechanism to use to validate that model. Okay. Actually, technically speaking, what happens is the edit form delegates the validation to that validator. Okay. Now, this is a really good example of the way Blazor has been built, and that's for extensibility and for customization and basically not to pen you into a corner. So while you can use data annotations and this validator ships in the box, you can also use a different validator, and I'll kind of come back around to that in a minute. The validation summary component, as you can probably guess from its name, shows a summary of the validation messages that have been thrown by the form. So we've got that in place now. So let's go and have a look and see what happens on our repairs, our new repair page this time. Excellent. So now we've got validation happening. Okay, we've got our validation summary at the top showing the various messages, and we've got these nice kind of borders going around all of the inputs. Now, I've added a bit of custom styling to do this. So this is the output, the actual HTML elements that get outputted by Blazor. But one of the things it does is it applies these classes to these input components. Excuse me. So here it's applied a class of invalid. But if I put a valid value in and tab out, you can see it changes to modified and valid. So you can use these in your CSS to add styling. You can see when it's valid, I put a green border around. What you can also do as well is if you don't like those default classes, there's a way that you can specify your own class name. So if you're using Bootstrap, for example, and Bootstrap has built-in validation classes, you can tell Blazor to use those names instead, and it will input those for you. So nice and flexible, nice and extendable. Cool. So this is looking pretty good. However, I'm not a huge fan of these validation summaries. I think a better UX is to kind of have your validation closer to the point where the error is. So I'm going to make one last kind of change on this form. I'm going to update all of those inputs to have an extra component with them. And this component is called validation message. And what we do with validation messages, you use its for parameter and you say what it's going to show validation messages for. And in this case, I'm just specifying each property of the model relative to the input it's next to. I don't need that validation summary anymore, so I can get rid of that. So let's just run a build and we'll go back now. And if we look at it this time, hopefully we will see. There we go. We're now getting validation messages directly under our input. So that's a much nicer design in my opinion. Now, we could leave it there, but what I sort of really want to show you as well is, like I say, this extensibility, the fact you're not penned into anything. Now, personally, I don't really like using data annotations. It's not that it's not good. It's not my cup of tea. I personally prefer using fluent validations. I think it's a It's a nicer library. I think it's more expressive about the rules, and it's a bit more sort of flexible to put things together. So what we're going to do is we're going to have a look at, now we've got data annotations running, is how easy it is to swap over the validation mechanism. So what I'm going to do is I'm going to go over to this repair model, and I'm just going to replace it. And I've replaced a bit too much. There we go. Oh, did I? No, I didn't. I pasted it with the wrong thing. There we go. That's better. Cool. So we've got that same repair model we had a minute ago. Okay, so we've got a name, issue, trade, contact number, all of the same stuff we did before, but we've removed that data annotations, those data annotation attributes from the model now. What we've got instead is now a repair model validator. So this is the syntax that this is what you do with Fluent Validations. You create a class, and in the constructor of that class, you specify the rules for your model. And basically, that's what I've done here. I've got the Fluent Validation equivalent of those data annotation validations going on here. So that's what this is doing. So now I've done that, I'm also just going to have to make a small change to my server, because the server does need a little bit of, one-liner bit of configuration in order to know to use Fluent Validation instead of data annotations. So I'm just going to pop this in here. Now, once I've added my using statement as well. So all I'm doing here is I've already installed the NuGet package for Fluent Validations here, by the way. I've just skipped that step. But I'm just adding Fluent Validation into the DI container, and I'm also telling it where it can go off and find the Fluent validators. So that validator that we've got over here on our repair model. Okay, it's going to go off and find that using reflection. Okay, and that's what I'm just telling it to go and look in this assembly to do that. Cool. So that's our model, essentially our model in the shared project, and it's our server configured at this point. So the last thing we've got to deal with now is our form in Blazor. So all I'm going to do is I'm going to replace that validator with this one. Okay. Now, I've installed a NuGet package here ahead of time. It's actually one of mine. It's called Blazor Fluent Validation. And all it does is it gives you that validator. Okay, so you install the NuGet package and then put that validator in place, and that's it. So what I'm going to do is I'm going to save that. I'm going to rebuild everything. And then if we go back to our app and refresh it, and literally it works exactly the same as it did before, except now we're using Fluent Validations instead of data annotations. So the reason I've showed that is just to show you that it's very, very easy with Blazor to get going with something out of the box, but also to move over to something else you're more familiar with or something you prefer. Okay. And there's lots and lots of stuff evolving now in the Blazor ecosystem, so that all of this stuff is kind of the hard work of all this stuff is done ahead of time for you, like creating that Fluent Validation validator. That's been taken off your hands. You can just install a NuGet package and get on with adding value in your particular application. Cool. So that's our stuff on forms and validation. So we've now got our form working and it's all valid and everything. So what we're going to do next is we're going to go and have a look at this dashboard. Okay. And what we're going to do on this dashboard is we're going to create a nice graph on there, because everyone likes a nice graph. It's always good to look at and it's pretty. So we're going to use JS Interop to do that. And the reason we're going to do that is because it's a good example of where you should probably think about using JavaScript. The reason is because JavaScript has got a lot of very mature, very stable, and very feature-rich libraries for doing charting. And they're also very efficient. They're very battle-tested. They're very performant. So I think this is a great example that we can use with Blazor to show where we can kind of take the best of both worlds. So what I'm going to do is show you how to work with a library called Chart.js, and more importantly, how you can wrap those libraries in C# code so that you can almost forget that you're using JavaScript under the hood. Cool. So let's go back over here. Now, what I'm going to do is I'm going to go into my www root folder, and this is where I can put my static assets for my Blazor app. And I've got this JS file, and in here I've just got a minified version of Chart.js. Okay, that's what that file is. That's just sitting there. And I'm going to go in here. I'm going to add a new file at this point. Which I'm just going to call chartwrapper.js. And I'm going to paste in a chunk of code here. Now I'm going to shrink a load of this up because this is just not relevant and it just really doesn't matter. So what I've done here at a high level is basically I've just created a simple function called build chart that takes in an element reference. That element reference is passed to chart.js, and that's and I use that to tell chart.js where I need it to render the chart. I create a new chart by calling new chart and passing in the element. And then I have to provide sort of 3 pieces of information. I have to provide the type of chart I want, the data to be rendered in the chart, and any chart options I want. However, I want to just be clear that all of this is boilerplate code. I've literally copied and pasted it from the chart.js getting started guide. There's nothing exciting going on in here at the moment. One thing I do want to point out, though, is the fact that I've got this special keyword here called export. And this is because we're using JavaScript modules here. So Blazor from .NET 5 adopted or included the ability to use JavaScript modules, which means we can kind of load these on demand in our components. Okay, and that's what we're going to do for this chart wrapper. Cool. So now we've got that. I'm just going to make a small addition to my index.html. I'm just going to add in a link to that chart.js, that minified chart.js file. I'm not going to add in a link to my chart wrapper file. Okay, we're going to deal with that, or Blazor is going to deal with loading that for us when we need it. Okay, so we've got that going. The next thing we're going to do is we're going to move off into this dashboard feature, and we're going to add a new component in here. I'm going to call this component chart. I'm going to pump a load of code in here. Now we're going to work through this because some of this stuff looks a bit crazy, but we'll go through it. First of all, I'm going to just jump ahead a little bit. I'm just going to show that I just want to call out, we're basically just using a standard HTML canvas element here. That's what chart.js prefers to render into. So that's why we're using that. What we are doing though is we're capturing a reference to this HTML element. We're doing that using Blazor's ref directive. Now, Blazor includes a special type called element reference, and that allows us to capture elements in C# to HTML elements. We can then pass that reference into JavaScript. Blazor will do the work converting that into a JavaScript reference and pass it into JavaScript, and it will all be valid. Okay, so we'll see that working in a second. The other thing that's happening here is a bit of dependency injection. So we're injecting a service, an instance of IJS runtime, okay? And we're injecting it using the inject directive. So this is how we do dependency injection in Blazor applications. We use @inject, and then we say the type that we want to inject, and then we give it a local name, okay? So _JS runtime in this case. The other thing that's probably worth pointing out while we're up here is the fact that we're implementing IAsync disposable. This is something, again, that came in with .NET 5. Obviously, Blazor supported iDisposable before that. But with .NET 5, it supports IAsync disposable. And we have that because we're going to capture a reference to that JavaScript module that we're exporting from that JavaScript file. And we need to be able to dispose of that when this component goes out of scope. So all I've got down here is a simple implementation, dispose async. And all I'm going to do is call dispose async on that module. Now that module is going to be stored in this IJS object reference field up here. Okay, so that's what that's doing. It's a special type to store those JavaScript references. And then in the middle here, we have a component lifecycle method. Now, Blazor components have 3 lifecycle methods. They have on initialized, on parameter set, and on after render. On after render is the one we care about when we're doing JavaScript interop. The reason for that is because it makes sure that the component has rendered once, and there's some physical DOM elements there that we can hook onto. This is a good example of what we're doing right now is a good example of why that's important, because we're going to try and we're going to pass a reference, this canvas element, into JavaScript. And if the component hasn't rendered first, there's no element to pass in, and we'll get a null reference error and it will all blow up. So you always want to do your JavaScript interop calls on the on after render method. Inside of that method, we're hooking onto this argument that it has called first render. This is set to true for the first time the component's rendered. And what we're doing here is saying, well, if it is the first render, capture the reference to that JavaScript module. We can then reuse that module as many times as we want throughout the lifetime of this component. In this instance, we actually only need to call it each time the component re-renders, but we could use it in other areas of the component if it's doing some more advanced stuff. So what I'm doing here is I'm using the JS runtime. I'm calling invoke async, and I'm saying I want to capture an IJS object reference. I'm using this special function that the framework provides called import. And then I'm telling it what file I want it to import, okay, which is that chart wrapper.js file that we just created. That's going to store a reference in module, and then I can call functions that are exported in that JavaScript file. So what I'm doing here is I'm calling the module. I'm saying invoke void async, so I don't need a return type here. There is a invoke async if I was getting a return type from JavaScript, and that's perfectly possible. And I'm saying call the build chart function. So we've got that over here. That's what our function's called. And what I'm going to do is just pass our chart container as an argument down to that function, okay? And that will be passed down as that element, and that will be passed to chart.js. So that's our component built. I'm now going to go over to the dashboard page, and we're going to stick our chart component in here, like so. And we'll rebuild, and we'll go have a look what's happened. So if we give this a refresh, and we'll see what happens. And we have a chart display. So it's not particularly exciting for us at the moment. This is all static data, but you can see we've managed to get our chart.js implementation working relatively quickly there, and it's showing the data and everything's working as we expect, which is nice. But let's make this a little bit more practical and a bit more useful for us, and let's tie it to some data that means something to our repairs app. So what we're going to do is we're going to kind of come over here, and we're going to update this this build chart function. So let me pump some new code in. So I'm going to shrink this options down again, because again, that's boilerplate and we don't care about that. What we've actually done here, or what I've actually done here, is removed a lot of the boilerplate code. I've just said what I'm going to do is I'm going to pass in the type that I want. I'm going to pass in the data I want to be displayed, and I just want you to render it, okay? So I've removed all of that hard-coded data out of there, and I'm just going to pass it all in from C# now. The nice thing about this is it's made this truly boilerplate. I don't really need to care about this at all now. This can kind of just sit there and do its thing until I need to, I don't know, enhance it with some crazy new functionality that I haven't thought of yet. So I'm going to close that down. What I now need to do is, because I'm going to pass the data in from C#, I need to create a class that represents what that data looks like, okay? So I'm going to create this C# class called chart data, and I'm going to pop in some code here. Now, again, you don't need to worry about the specifics of what this code is doing, but just take my word for it. It is a C# representation of that data structure that chart.js needs, okay? So it needs a list of labels and a list of data sets in order to render. So that's what that's doing. It's just replicating that structure in C#. Cool. So now I've got that. The next thing I'm going to do is I'm going to make some updates to my chart component. So I'm going to add in a couple of parameters. Now, these are the things I mentioned a little earlier when we were talking about forms, and I said about binding to that value parameter that the input text component's exposed. Well, that's essentially creating a public API for a component. That's what parameters do. They allow us to create a public API for a component. So what we're saying here is we want the consumer of this chart component to be able to pass in the data they want displayed by the chart, and also the type of chart that they want to see that data displayed as. And parameters are just public properties that have that parameter attribute assigned to them. That's all it is. And now I've got these two public, like I say, these two public APIs for my component. Cool. So I've got those bits in place. The last thing I'm going to do is I'm just going to update this this JavaScript call. And all I'm doing there is I'm just updating it to pass in the type and the data that are being set by those two, or being collected by those two parameters, and passing them down to that JavaScript file. So that's my chart component updated. I can now go to my dashboard page. I'm just going to update this. So first things first here, I've got a lot more code in, a lot more stuff in my code block now. So what's happening here is, firstly, I'm now using the oninitialized lifecycle method. This runs once in the lifetime of the component. And what we're doing here is a really good example of what it's used for. It's to get initial data for the component, or do some initial setup for the state of the component. So what I'm doing in this method is I'm using the HTTP client, which I'm now injecting up the top here. And I'm making a call to my API to load my repair data. Once I get that repair data down, I'm going to pass it into this private method I've got called create chart data. And all this method is doing down here is it's just taking my data and it's reshaping it into that chart data class that we just created. So that representation of the data that the chart.js library needs in order to render it properly. So that's what's going on there. That chart data is being stored in this field, chart data, and that is being passed into my chart component now using that public API we defined. So you can see now I can pass into that data parameter by specifying data as an attribute and then the value that I want to pass into it. And the same with the type of the chart. I've got my type parameter and then I've got the value that I'm passing into it. What's really nice here is like IDEs like Visual Studio and JetBrains Rider, for example, they've got some good Razor tooling in. It's being improved a lot because it does need to be improved a lot. But what's really cool here is it understands that this isn't a string value. It understands that it is a typed value. So it understands that it is a type of chart data. So if I get rid of this, for example, I will get IntelliSense now. So I can do underscore chart data and I get completion. So all of this stuff is understood. It's a nice experience to work with as a developer. Cool. So now I've done those updates. Let's see what this looks like. So if we go back to our dashboard and refresh, let's see what things look like. Cool. So we've now got our data being displayed in our chart properly. We've got our completed repairs here on the left, and we've got our outstanding repairs over here on our right. And we can see that really easily and really nicely. Now, what's good about this, the work that we've just done is that we've now wrapped chart.js and we've kind of created this C# API to it with this chart component. So what that means is if I go back over here and I decide I don't like pie charts, I like line charts instead, I can just say, give me a line chart instead. I can come back over here and I can refresh my page. And now I've got a line chart being displayed. But that looks a bit rubbish as well. So I can come back in here and instead I can say, now I want a pie chart. So I'm going to do a pie chart and we'll just spin that one up. And now just like that, I can refresh my page and I've got a pie chart instead. So I could package this up into something called a Razor class library, which is how we can share components between apps. And I could share this with sort of all the apps in my company, or I could publish it to NuGet. And now someone can just use my C# library or my C# wrapper code. And they don't really need to care that I'm using JavaScript under the hood. And one day, if a better chart library emerges from the .NET world, well, we can just strip out that JavaScript code underneath, replace it with the .NET version, and no one needs to be the wiser. So it's an interesting system going on here, and hopefully I've shown that it's relatively easy to work with. Cool. So that's JavaScript Interop. So the last thing we're going to tackle is forms and validation, and not forms and validation. We did that first. Blah. I haven't had enough coffee tonight. Authentication and authorization. So that's the last bit. So what I'm going to do is I'll just get rid of some of this stuff. So I'm going to start off with the first kind of premise, really, with doing any kind of security stuff is secure the server first. So what I'm going to do is I'm going to open up this repairs controller, and this is what we've been calling from this application. And this is just returning this hard-coded data. So what I'm going to do first is I'm just going to make sure I've secured my API before I do anything else. So I'm going to add this authorize attribute onto my API controller. And now I've secured that. I need to be authenticated with this API now to get to any of this data. So that's my first job. The reason I'm doing this first is to make the point that the Blazor WebAssembly app, even though we're running C# code and whatever, this is running on the client. It's a client app. It can't be trusted in any way, shape, or form. So anything that comes from that has to be untrusted by default. Okay. Now, just as a quick word of what's going on here, in order to kind of show you a bit more of what happens under the hood, I've rolled my own login controller. Please don't do this. This is horrible and this is not secure and this is probably very, very bad. But it does allow me to kind of explain to you what happens in Blazor. I'm quite literally hard coding username and passwords here, and I'm generating my own JSON web tokens and security encrypt keys. It's just not a good idea. Like, go use Azure B2C or use Auth0 or use someone who knows what they're doing. Don't copy this code. Okay. But what's going to happen here is when we do log in with a successful username and password, it's going to generate a JSON web token that it's going to pass down to our client app that we can then use to communicate with the API going forward. Cool. So we've got those bits. The next thing we're going to do is now we go back to our client and we're going to actually perform a similar task now. We're going to work through each of our pages. And on each of these pages, we're going to do a similar thing. We're going to use that same authorize attribute, in fact, the one that we just used on our API controller. We can use the same one in Blazor. And we apply attributes to our components using the attribute directive. So I'm applying this authorize attribute to my dashboard page here. I'm also going to go on my new repair page. I'm going to do the same thing. And of course, I'm going to go on my view repairs page. And I'm going to do the same thing. Cool. So I've now got an authorized attribute on each of the pages in my Blazor app. But on their own, they're not going to do anything. Blazor doesn't know what authorized means at this point. It doesn't understand how I vet my users, how I make sure that they're authenticated and what that means. So we're going to work on doing that next. So I'm going to show you a very manual way of doing this. Like I say, again, I'm just reiterating this lots because I don't want anyone to get scared off thinking this is really complex. There's a load of stuff out the box for working with general OIDC providers for B2C specifically and for Azure AD. It's all kind of pre-configured for you. You just install a NuGet package, drop in a couple of settings, and it just works. I'm showing the more manual route to show you kind of what's going on. So what I'm going to do is I'm going to create a folder here. And I'm going to call this folder providers. And inside of here, I'm going to create a new class. Cool. And what I'll do is I'm just going to dump some code in here. Lovely. Now, there's a few things going on here, and I'm going to shrink all these methods up again just to work through it. So in order to understand what authenticated means to an application, we have to tell Blazor what that means, and we have to tell Blazor how to authenticate a user. So that's what I'm going to do here. I'm going to inherit from a base class called Authentication State Provider. And by doing that, I need to implement a method called getAuthenticationStateAsync. Now, this method is going to get called by all of Blazor's internal auth-aware components to find out whether the user is authenticated or not. So that's what we've got. That's our job in this method, is to return whether the user is authenticated or not. Now, in order to do this, I'm going to look for a token in the browser's local storage. I'm going to look for a entry in local storage with a value, with a key of token, and I'm going to try and see if it's got a JSON web token in there. If it's got one, I'm going to try and construct a new claims identity using that token. Otherwise, we're going to create an empty claims identity. And then if I've got a token, again, I'm going to attach that token as an authentication header to the HTTP client so that every time I make a request to the API, that token will be included with the request. Once all of that bit of logic is done, I'm going to return a new authentication state from this method, and it's going to return a new claims principal using the identity. If that identity is empty, it'll be an empty claims principal, and effectively, it's the equivalent of saying the user is not authenticated. Okay. If I've got a token, I'll have an identity, I'll have a claims principal, it will show me as authenticated. So that's what's going on in there. I've also got a couple of helper methods here, which we'll see in action in a second. And what they're used for is firstly for logging in. And once you've logged in, we get a token back from the API. This method takes that token and it stores it in local storage so we can pull it out later. And when it does that, it then calls this notify authentication state changed event. And that triggers Blazor to call this method, this get authentication state method. And then that triggers the UI to reload with the user's new authentication state. I've also got the equivalent for logging out where I remove the token from local storage. And again, I trigger authentication state changed event. So now we've got that, we just need to wire this component up. So I'm going to do that in the program CS file. Now, Blazor WebAssembly apps don't have a startup class. The reason they don't have a startup class is because they don't really make a lot of sense in Blazor WebAssembly. We don't have a request in a Blazor WebAssembly app. It acts more like a desktop application. It gets downloaded into a browser. The instance lives in that browser instance, and then it dies when that browser instance dies. This isn't a long-running thing on the server that's handling lots of requests. So that means that middleware has no purpose in Blazor WebAssembly. So that removes the configure method from startup. And at that point, we only have the configure services method, Well, we might as well just do that in program main, and now we don't need a whole separate file. So that's what we do here with Blazor. We can configure our service container here, and we can set up any services we need in this file. So that's what I'm going to do. I'm going to pop in some services here, and then I'm just going to add some using statements. I think that's all of them. Oh no, one more. So the first thing I'm doing is I'm adding some Microsoft infrastructure here. I'm adding this authorization core, which sets up all of the services in the framework for authorization. I'm adding in this Blazor local storage, which again is one of my libraries for working with local storage, and that sets up some services for working with that. Then I'm going to add that token authentication state provider we just created as a scope service. Now, it's worth pointing out at this point with Blazor WebAssembly that scoped and singleton are the same thing. Okay, scope services are tied to a request lifetime in a server-based app like MVC or Razor Pages. There is no request in Blazor WebAssembly, so scoped is the lifetime of the app. So scoped and singleton, they're exactly the same in Blazor WebAssembly. The only thing that keeps the same behavior is transient. Every time you request an instance into a component, you'll get a new version. The final thing I'm doing here is I'm saying for any component that requests an instance of the authentication state provider, what I want to do is instead give them my token authentication state provider. And that's so it's going to execute my logic for that get authentication state async method. Okay, so that's what that last little bit is that's going on there. Cool. So we're nearly there. We're just going to go off into this app Razor, which is the entry point. It's the top component in our tree of components in our Blazor app, and it contains Blazor's router component. Now, this router component doesn't understand that authorize attribute yet. It doesn't understand that it shouldn't route us to a component if we're not authorized to view it. So that's what we're going to do next. We're going to tell it how to deal with that. So we're going to replace this root view component here. Okay, and we're going to replace it with something called an authorize root view. So this, as you can probably guess, is a component that is aware of the authorized attribute, and it also is aware of that authentication state provider class base class that we talked about a second ago. So what this will do is when we try to navigate to a URL, it will spot if that has an authorized attribute. If it does, it will call that token authentication state provider. It will see if we're authenticated, and if we're not, it's going to, in this instance, send us to this login component. Okay. Because what we've done here is we use this not authorized template, and we said the user's not authorized, render the login component. Okay. And the login component is over here in this login feature folder. And at the moment, it's currently commented out, but we'll just comment that back in. And this is, again, it's just using a simple edit form, and it just collects the username and password and posts it off to the API. And if that's successful, if we've logged in with the correct username and password, it's going to call our token authentication state provider, and it's going to use that helper login method we looked at earlier in order to store the token. Cool. So I think that's all the bits that we need at this point. So if we now give this a build, and we'll go and have a look and see how our app behaves now. Cool. So you can see we've tried to go straight to the dashboard page, but we've got that authorized attribute, and now we're seeing the login screen. If I try to go to any of the other pages, new repair, view repair, you can see that it doesn't change. We're just getting the login. We're getting the login screen no matter where we go. So let's see if we can log in now. So I can log in as a user. Let's see what happens. So on a successful sign in there, I can now access my dashboard page. So that's great. I can see my chart. I'm accessing the data. I can get to my new repair page, and I can get to my view repairs page. So that's all good. Everything we've done now has worked, and that's all good. If I open up the browser dev tools, if I come back to my view repairs page, you can see that we're making this network call. And if I look at the headers down here, you can see that there's that bearer token header with our JSON web token in it. That was being attached by our token authentication state provider. And if I look at my application tab, I can go in local storage, and you can see my token is being saved there in local storage. And at the moment, we've got no way of logging out in a graceful way. So I can just delete this token out of local storage. If I refresh the page, I'm back to my login screen. So everything's working how we designed it, which is great. The only thing is, it would be nice if we could kind of have a bit more roles-based stuff. So we maybe don't want all like users. We don't want them to be able to access everything. You know, we maybe want this elevated role to be able to access the view repairs because that's got some phone numbers on it, which is maybe a bit more sensitive. So how can we do like role-based authorization? Well, what we'll do is we're going to go back over to our view repair page, and we're going to update this card component, and we're going to swap it for a slightly different one. So what we're doing here is we're using a different component called authorized view. Okay, so this again is something that comes out of the box. And what we can say with authorized view is we can say, right, we only want certain roles to view this data. So you can see this doesn't apply to the whole page. The heading's going to display and everything. It's just the stuff that's inside of this component. And what we're saying here is for authorized users, i.e. users that are authenticated in the role of something called planner, then we're going to display that same card we had before, which displays that table of repairs data. However, if they're not in that role of planner, we're going to show what's in this not authorized template, which is another card component, but this time it's just saying a friendly message saying you're not authorized to view this data. So let's give that a go and see what this looks like. So let's refresh things here. And if I log in this time as a user, I can't type. There we go. So now I've logged in and I'm authenticated as in I'm logged in, but I'm not authorized. Okay, so I'm now seeing this not authorized message instead, but I can still go to my new repairs page because we don't have any role-based auth there. And I can still view the dashboard data. I just can't get to those sensitive phone numbers. So the final thing is it would be nice to be able to log out without having to delete a token out of local storage. So let's just complete the loop really and add that last little bit in. So in order to do that, I'm going to go in my dashboard feature and I'm going to add a new component in there called user status. And inside of that, I'm going to pop in another authorized view component, but this time I'm using a slightly simpler implementation. I'm not saying you need to be in a particular role. I'm just saying you need to be authenticated in order to view this content. And what I'm going to do is I'm going to output a little menu and it's going to say hi, and it's going to spit out my login name. And I'm also going to put a button on here which has a click event handler. So I'm going to say whenever I click on this, this button, I want to call the logout method on my token authentication state provider, which I'm injecting up at the top here. And that's all that's going on here. If I'm not authorized, then I won't see this menu. I won't see any of this stuff. So that's my user status. And if I go back to my, actually, I put that in the wrong place. I always put that in the wrong place. That shouldn't be there. That should be in my header bar. There we go. That's better. So if I go to my header bar now, I can update that to have my user status component in it. Cool. There we go. So that hasn't quite caught up yet. That'll catch up in a minute. In fact, this will probably break now. That's my fault for always putting that in the wrong place. Oh, it worked. Huh. I'll wing that. Let's see what happens. Cool. So that's not done what I expected at all. What did I get wrong there? Give that a rebuild. You're gonna like it this time. There we go. Now let's try it. Aha, worked. Cool. So as you can see, I now have it printing out saying hi, my login name, and now I've got a logout button. So I can now click this logout button. It removes my token from local storage for me. I can then come back as a planner and I can sign in as a planner instead. And now as a planner, I've got that elevated permission. I'm in that role. I can now see the repairs data. I can still get to the other areas of the app as I could before. And my name's updated up there. Whoa, so that is it for the code. Let me just finish off by just pointing you at some useful resources if you're getting into Blazor. There's a few on here. I'd say the two main ones really are the official Blazor site at blazor.net. And I'd say the awesome Blazor repo, because that's got links to basically everything else. It's a phenomenal repo. It's very, very well maintained. It's got a link to basically, I think, every Blazor thing that's ever been produced ever. It's crazy. There's also a short link for Awesome Blazor, which is probably a lot easier to remember. And I should have updated this slide. And that's aka.ms / awesome Blazor, which is probably a lot easier to remember. So yeah. Anyway, that is it. I know I've run a bit over, so thank you very much for indulging me. And yeah, if we've got any questions, then happy to answer them.
I would have a question, Chris. How did you make the SAS stuff working without need of compilation? Because I only saw the SCSS files, but not the CSS files. So which way you used? Because I only know the delegate SAS package and to compile on build time, and this is not that convenient.
Yeah, so on this particular project, what did I do with this one? I think I'm using one of the plugins from Mads Christiansen. It's called something compiler, and the name's completely escaped me now. But it's basically a NuGet package and a plugin you can install, and it will do the compilation for you. This is the config for it. So at the moment, what I have is a plugin for my Visual Studio, actually. So he has a plugin for Visual Studio and a NuGet package. What happens here is when I'm using Visual Studio, it's going to go and find all my SAS files and compile them into a CSS file for me. When it's in a build pipeline, there's a NuGet package, and that will do the same thing as the plugin does in Visual Studio. It's probably something I probably should look at updating, because in all honesty, I don't actually use this method anymore, but I kind of don't do this at all. I now use Tailwind CSS for pretty much everything, which is a utility-based CSS framework. And it's just very, very, very good to use. If you've not heard of it, it's definitely worth checking out. So Tailwind CSS, you do things like you build up CSS by just using utility classes. And as this demo is showing you, you can very quickly iterate to create these kind of really rich, interesting looking UIs. They do have out-of-the-box components as well, but this is basically what I use for pretty much everything. At the moment, this requires still to use some basic NPM stuff. I don't personally mind that. I know some people are quite sort of won't use NPM at all costs, but I'd rather use a good tool personally, and NPM is just better at this than .NET stuff is. So that's what I'm using. But to come back to your original question, it's that, like I say, it's that compiler by Mads Christian thing. I think if I have a look at my extensions, actually, that will probably tell me. No, I don't know. Sorry. It'll come to me at the moment I get asked another question, I'm sure, and I'll blurt it out.
Thank you. Anyway, thank you.
Web compiler. It's called Web Compiler.
A couple of people, Chris, were asking in the chat, is there like have you got a repo of this on GitHub that we can kind of check out?
I think someone asked me this the other day. I don't think I've actually got this as a public repo. I will do. I'll make this public, yeah, so people look at it. I think I've actually got it on my to-do list. So I'll make sure that's done, and I'll ping it out to it when it's out, and yeah, you can go have a look at it.
Well, we normally publish show notes anyway, so if we can include that in the show notes and then on the .NET Oxford website.
Yeah, great.
I can see Todoist in your taskbar, so is that...
I live and die by it. Well, me and you have already had this conversation.
Yeah.
Yeah.
Well, I find it quite interesting that you've got Evernote and Notion next to each other. It's like, fight!
Yeah, and that's why I keep them next to each other, so I can bump each other in the head. Yeah. I went all in on Notion, and then I pulled back from it. Yeah.
It's amazing.
Yeah, it is great. I do like it for a lot of things, but some things not so much. But anyway, that's a whole different conversation.
I'll be here for hours if we get into this. Does anyone have any more questions before we wrap up?
Sorry to bother with more questions. I have another one. Chris, you use your package Fluent validation, which I also like to use. And I had problems with localization and using the Fluent validation. Did you ever use that together, and how did you solve it? I could not inject it and had really hard time to make it work together.
Yeah, I've actually got this on my note of blog posts to look at, because someone else brought this up to me as well. I've not actually had to do any localization with fluent validations yet. But there shouldn't be any reason with the way Blazor handles it. There shouldn't be any reason why it shouldn't work. So I do have it on my list. I'm really fortunate. My company actually gives us a day a week to work on open source and blogging projects. So I'm actually planning on writing this blog post on Friday. Believe it or not.
Okay.
So you've asked some really poignant questions actually. But yeah, so if I actually get through that in the way I think it will work, hopefully there'll be a blog post next week on my blog. So I keep an eye out. And yeah,
I would appreciate. Thank you.
I'm just looking if there's any more in the chat.
There's a question from Lance about how you said you wouldn't use your auth method in an actual project. So for those who want to use Microsoft Identity and local SQL DB, what would you use, if not the code that you showed? Can
I answer? I wouldn't do it. I'll be honest. The problem is with, and it does depend on what your scenario is at your company. Like, all joking aside, I appreciate that you can't always go to a cloud provider or a SaaS service, but this stuff is stupidly complicated and it's incredibly easy to get wrong. And we all literally see almost daily on Twitter the latest blurge from Troy Hunt about who got data breached. And I just think this is one of those things that developers, unless you're a highly specialized security dev, you're probably more likely to get it wrong than you are right. So if you've got to do some form of on-premise stuff, use something like Identity Server, where you've got sort of a lot of the hard work done, for you. Although, don't get me wrong, there's still a huge amount you can misconfigure in Identity Server, and it's still a beast to learn on its own. Recent years, I've stopped using any on-prem, like any of that hand-rolled stuff entirely. And I mean, Azure B2C will let you have 50,000 active logins before you start being charged. Auth0 will let you have 5,000 active logins before you start being charged. A lot of the time, I've seen some developers who could use these things. They're just choosing not to. And I think the time's there now to stop this and move away. If you genuinely have to do it in-house, use Identity Server and probably spend some money on a consultant who really knows how to configure it to teach your team how to work with it properly. What I did there does technically work, but it's a great example of it might work, but don't do it. It does generate a token. It is a valid JSON web token, but there's so many ways that could probably be exploited by someone who it's not even funny. So honestly, it's just not worth. Don't copy that. That's my ultimate message. Don't copy that.
Don't push that up to the repo.
Yeah, if that starts appearing in production apps, I'm denying all responsibility. I never went near.
It's got your name and an MIT license.
I did notice, I think, look, I was tracking back through the comments now. I can actually see them in the chat. I noticed some people talking about hot reload and bits like that. I think, as someone pointed out, hot reload is part of .NET 6. It's actually in the current preview of .NET 6. It shipped with preview 3. It's really good. Like, it's stupidly quick, like really, really quick. It's also incredibly brittle in the wrong scenario. It's definitely an example. I actually played around at the weekend while I was getting ready for this talk, and I was updating the app here. I actually upgraded this to .NET 6 specifically so I could show the hot reload stuff. And I hit a few scenarios where it broke, which are known scenarios where it breaks. It's just a bit too clunky. But when it matures and later through the previews, it'll be a big help. What I showed you was it was the current development style. It is clunky. I'm not going to lie. It is doing manual rebuilds, manually refreshing the browser. I kind of like to be really upfront and honest about that at the moment. The hot reload will make a ginormous difference, and it, like I say, is a very, very good system they've built and stuff. There is actually an intermediate system where you can use .NET Watch Run, which I think someone else pointed out. Mm-hmm. That works sometimes. What it does is it will. Unlike .NET Run, which will just run your app and then you kind of get a URL and you copy that and paste it in your browser and run the app. It will spin up the browser for you and it will watch all of the files in your project. And every time you change one and save it, it will automatically rebuild your project and then automatically refresh the browser, in theory. Although in my experience, I'm obviously on Blazor almost every day. I haven't had it working for over 6 months. I don't know why it stopped. It stopped. And I work across a Mac. I do my main development is in a Mac, on Mac OS. So I'm using the command line there a lot. I also do a lot of stuff in Windows as well. And it's broken me on both. It sporadically works. It sporadically more often sporadically doesn't. So like I say, I think those are intermediate steps. And I think hot reload in .NET 6 is going to be a bit of a game changer when it comes to productivity.
Any more questions before we wrap up?
Yeah. How do we deploy this to production? Like any optimization steps, or like just like we do normal .NET deployment, or?
Yeah, .NET Publish. .NET Publish. So you just run .NET Publish. It's going to run it through a compile step. It's a more rigorous compile step when you use .NET Publish. So what happens currently, and just wondering whether I'm just going to quickly reshare my screen. Actually, I'll show you. I want to show you something actually around this. So if I go back over to the browser and go back to my app here, if I go into the cache storage, this is all the stuff that's been shipped down to the browser. Okay, from my with my Blazor app. This is everything. So if you scroll down, you can see. Here's my Fluent Validation DLL, my local storage DLL. Here's my client, the client project we've just been building. That's the DLL for that. We've got the shared project DLL right there. We've got BUnit for some other stuff that I've worked on. We've got Fluent Validation. We've now got framework components. We've got the actual .NET framework stuff there. We go lower down again. If we come all the way down to the bottom here, after we go past all of these framework files and bits and bobs, right at the bottom, we also have this .NET.wasm file, and that's that .NET runtime compiled to WebAssembly. The reason there's so many here is because the entire framework is being downloaded to the browser at this point while I'm in development to give me the most flexibility that I can possibly have while I'm developing this app. When you do .NET Publish, it's going to run something called an IL linker. So this is something that got kind of it originally started life in the Xamarin team, and they used it for tree shaking their Xamarin apps. And the Blazor team adopted it and have sort of optimized it, improved it. And when you run .NET Publish, it runs over all of these DLLs and looks at all of the methods that you're using in your app, and it strips out everything that you're not using. So it minimizes the size. At the moment, this is downloading somewhere in the region of, well, it actually tells you on the console. I think if we scroll up here, 8.93 meg at the moment in terms of assets. That if you do .NET Publish on this specific app, that will come all the way down to about 2.2 meg. So .NET Publish is incredibly important when you're pushing to production with Blazor WebAssembly, because without that, it won't go through this optimization step, and you'll end up with these huge, great big downloads. But obviously, you just call that in your build pipeline, Azure DevOps, whatever. I've got blog posts on that. You can put it in a Docker container. It's up to you. Do what you want with it. But it just, you just treat it the same way as you would any other .NET app.
Can I ask you a question, Chris? Near the beginning, when you're talking about you need a constant connection for this to work properly. And then you also mentioned basically being able to stuff the compiled app onto Netlify and serve it down as a PWA with a service worker and a manifest file. So once you've already got that manifest file and the service worker, I'm guessing that then doesn't necessarily need a connection if it doesn't need any resources outside of itself, if you've already got all the data in the app. So as an example, if you were just kind of collecting data that you were going to then later submit to the server, that's all kind of doable without the connection, right?
Yeah, so there's a slight crossover there. So when I was saying you had to have a stable connection, that was for Blazor server.
Right, okay.
And we've been looking at Blazor WebAssembly. So you're quite right with Blazor WebAssembly. you can put a service worker and a manifest JSON in there. You can store data locally in local storage and sync it when a connection comes back. That all works in the same fashion as you would with a JavaScript app. That same kind of principles. Yeah, but Blazor server requires a constant connection because ultimately the only thing you have running in your browser is that Signal R client, right, and a bit of and a small Blazor runtime that updates the DOM, and that's basically it. So, so yeah.
Cool. Awesome. Thank you.